Здравейте, non-Bulgarian speaking people. Супер. Най-после. Не, като правя някаква лекция на английски ми дават много лоши оценки. Днес ще говорим за Jigsaw. Jigsaw е начин Java да стане модуларна. След сумати години всички останали езици го направиха, дойде ред и на Java.
Sorry, we're not Bulgarian.
Okay.
I don't know if you noticed, but Romanian, so English.
Yeah, my Romanian sucks. Okay, English.
Maybe your English doesn't suck, okay?
Hope so. I get bad grades if I do it in English. So this talk is about Jigsaw. Jigsaw is, it took like, I don't know, 6-7 years to get it done. 3 versions, like the Bulgarian e-government project, a lot of money put into it and nothing happens. The same thing in here. But it looks like this time is going to happen. Actually, the main reason why Java 9 is delayed for a year is these guys here. It's not yet fully done. We'll talk about how the modularization is going to happen in Java Standard Edition 9, and I'm going to give you a lot of examples. So most of the talk is going to be code and a couple of slides on what this means for large-scale projects and what you will get to get these things done. And I'll show you the coolest thing here is creating a custom Java runtime environment. It's really, really, really cool. It's a new thing. Okay, that's me. I work for a small company. I do security in Java and software. I'm part of the Bulgarian Java user group, and we organize J-Prime, and I ride motorcycles, which is, I'm out of the 3, I'm most proud of the last one. Okay, what are the, I'll give you like 10 slides on what the problems with the current Java. Do you guys see well? I can move a bit. First thing is, these guys, like a Raspberry Pi, is powerful enough to run Java. I like a year ago, I built OpenJDK 9. They didn't distribute images yet, so you had to build your own. On one of these guys, it took like, I think like 9 hours. It was really, really, really hot. And the problem is, these guys can run Java, but the runtime environment is really, really, really heavy. It's more than 100 megabytes. And if you go to a cloud, in a cloud, every single bit of memory and disk space is, you pay for it. So if you have a lot of virtual machines, you load a lot of unnecessary stuff. And since Java doesn't have anything like the .NET application domains, you cannot run 2 applications in the same GRE, because if one of them crashes, it's going to kill the other one. Sorry. And so here, making the GRE small is going to help a lot, because the cloud is the new thing, but the cloud is not cheap. Another thing is the JDK is messy. These are all the dependencies between different packages. So as you can see, a lot of loops, cycles, and stuff that is not cool, like cycles and dependencies is not cool. ClassPad is messy. I think this is Hadoop. All of these images are stolen from Mark Reinhold. They make really, really good at presentations, so I think I stole a few of them. Don't tell them. And we want to move this thing to a more understandable thing. And last but not least, people are using internal APIs, and there is no mechanism to stop them. So there are a lot of products that depend on stuff that is not supposed to be available for the public. For example, SunMist can save. The other one is base64 decoder. I don't know why that's internal or hidden. It just decodes base64, so it makes sense to be available. And the last thing is securing the platform in terms of when you execute code to limit what the code can do. Kinda not very easy. Now we'll go in separate problems one at a time. So the first thing is the source code. It's in Mercurial in a open source repo. You can go and download it. This is for OpenJDK. What they do is they're not using Git. Probably one of the very few people that don't like Git, don't want to use Git. I don't know why. So they move it into a package name. So this is the Java-based package. So they move the code in there. So there's native stuff in here, native methods, and the native implementation is part of this module. They renamed Solaris to Unix, and now they compile repos. They don't compile, now they compile modules, not repos. And because the JDK is a lot of repos, like I don't know if anyone has built the OpenJDK, probably Martin. You go to a repo, you download a script that downloads stuff from 10 other repos. And so they don't trust you to do it yourself. They give you a script to do it for you. And the solution is JEP 201 that changes all that. So it's no longer monolithic. The code is split into blocks that have very when they depend on themselves, there are no loops. And here the JDK, the GRE is, I don't know if that's really well visible. So what they do is the Java base from the previous slide is here. Then we have Java logging. Then we have something else. Then we have something else. Then we have Java SE. And then we have Java SE.EE. I want to show you something. So if I come here, this is my terminal, because IntelliJ does not support JDK 9. What I can do is so list all files, order by size, human readable size, Java home/mods. Ooh. Sorry. So what we do have here is, like, we don't have the RT jar no more. It's gone. It's dead. We have modules. Java-based modules here. We'll talk about these guys a bit later. We'll describe what these guys are. So this is the biggest one, and this is the next one. Like, I don't need Java Desktop for most of my applications, right? I don't need Java FX. I just saved 24 megabytes. I don't know what this guy is for. So the ones that start with Java are part of the JCP process. So they are governed by Oracle, IBM, Red Hat, and so on. The ones that start with JDK are not governed by the JCP process. And this is all of them. We can do... Want to see how big the directory is. Jmods, 99 megabytes. Okay, let's go back. Zooming out. So yeah, and this JEP, this specification, the JEP 200, specifies what requires public is. We'll talk about this. This is like a transitive dependency. And these are all the modules and how they depend on each other. So the Java base, this one, the small guy here, is like a Java lang object. You depend on it implicitly. And the JDK knows only about this guy here. Everything else is pluggable. So that's everyone depends on the Java base. The JMods are not well described, and that's on purpose. They want to change them because they're not sure they're the best yet, but they give you like a working copy of what's gonna happen, and we can actually see what's inside. I can do the Java base JMod list. Let's see what that's gonna give us. 1, 2, 3. and then Java base. Okay. So these are all the classes, a lot of classes in this archive. And we can see stuff that is binary. Somewhere there should be stuff that's binary. Yeah. Because I'm on a Mac, you'll see SO on Windows machines or DLL on Windows machines and SO on Linux machines. DYLib is for me. So even the native stuff is not lying around in the GRE. It's hidden. It's packaged in a JMod. And we can describe the same thing. So what I'll do is I have this command here. What I can do is I can do JMod describe, and then I'll use the third parameter from the last query, which is a trick in Bash. And then it's because I want to do it again. All the uses, so these are things that are pluggable. This is the version 9.early access. Exports. So this is visible to the outside. And now we have exports too. So we export this package. These are all Java packages. It's nothing new. To this guy. So I limit the access to this guy to only be visible to this guy here. So only this package can access, this module can access this package. Conceals means these packages are not visible outside. Even with the reflection, set accessible through will not work. You cannot access these ones. Some misconceived. I don't see it. So somewhere else probably. Caches and so on. Let's get back. So yeah, I can export, but I can export only to someone I specify. So without the JDK modules, this is what the module system is going to look like. We have Java base, which is Java long object or something similar. Java SE, and then we have compact, what's that called? Profiles. Profile is like they're like a label. So a compact profile is gonna be a very simple Java base. Compact 2 is gonna have RMI and SQL, and then compact 3 is gonna have some more stuff. And then you can use these guys, but you can make a system that only uses this guy and this guy, for example, and that's you can do that. It's possible. And then you have these guys are still not dead yet. Like it's still inside. Hopefully it's not too big. Internal APIs. So Sun misconceived, it's a huge problem, but there are a lot of tools that use Sun misconceived to make fast Java applications. Sun misconceived allows you to go off heap and create stuff in raw memory and skip the object model in Java. And there are a lot of tools like caching providers that use Sun misconceived. So they don't have an alternative yet, so you can use this guy still. They're gonna provide a managed alternative soon, some like nobody knows when. And some of them they will deprecate, which means they'll die in Java 10. And some of them will be rewritten. Some of them will be allowed to be used with a special parameter when you compile and run. The GRE is too big. Yeah, it's 100 megabytes, and the solution for this thing is, since we have JMods, is to create. This is the last slide, so you can't leave earlier than the last slide. We'll use a tool called JLink that's gonna allow us to build a custom GRE that works. Another problem, putting everything together. This is, there's a JSR. JSR has specification request, Java specification request. There have been several versions of Jigsaw before this one. They had different archive system, new jars, new way to do that. This is the latest one, and it's going to be implemented in this enhancement process. 261 doesn't matter, just numbers, but it's everyone agrees on this thing. Like Oracle agrees, Red Hat agrees, SAP agrees, all the big ones agree. So it's going to be this one. More problems. This took several years. Cyclic dependencies on packages. A lot of work went here. Like silently, you don't know that, but now Java 8 does not have cyclic dependencies. And this took several years. Several formats were proposed. I think the JMod and the modular jar are the new ones, the latest ones. And too bad, Oracle doesn't like OSGI. I don't know what the problem is here. Dynamic loading or unloading is not going to happen. So OSGI is not going to get a boost. And the modular system is not an OSGI alternative. The modular system is static. It happens on compile time. That's it. It's enforced on runtime, but it does not change on runtime. So OSGI, different story. OSGI, the main problem with OSGI is forcing classes to unload, right? You can load like a package, and then the classes inside may refuse to unload. So there's no mechanism for that yet. So no luck for that. I don't know what the reasoning is. And I was on a session with Mark Reinhold, and I asked him, like, is this going to change soon? The answer was no. So it's not going to change in Java 9. It's not going to change soon in the future. So, examples, code. You need the JDK early access with Jigsaw, so it's a downloadable thing. Oops. Sorry. No scrolling then. So you need to download this thing here. It's nightly build based. And then in class visibility, what we had until Java 8 is public friendly or package private, protected and private, right? So with the module system, the public gets a boost. Public can be only visible to the module, can only be visible to some modules, or can be visible to all modules. So the module, the public to all, this one, is like the interface of your module. Like this is what everybody else is going to use. This is the internal part of your code. And this is very specific in several cases where they gotta do some stuff in the JMod or in the jury. Creating a simple module. So creating a module is just one change. The change is module info.java. That's it. Everything else is the same. What I have is a logger. So when I do log string message, I do system out print line, logger plus message. And then I have this guy here, which says I require the Java base. I can skip this line because it's implicit. I always depend on Java base somehow. And I export this package. So this class in here, so this package is exported and visible outside. How do I compile? I'll compile in this guy here. We'll see how this goes. Oh, that's... Okay, I'm sorry. So what I do is, currently I'm in here. And I have a module called logger. Since IntelliJ does not support modules in Java 9, and it does not support Java 9 itself, this is not gonna work. But I still need an IDE to like make it more sane. What I have is, I have the module info, yeah, everything like it's not being understood. Like NetBeans supports modules, but I don't like NetBeans, so I'm not going to use it. And I have this module, and it exports this package. And inside in here, I have a log, which is very, very simple. Then I have another module. So let's build this guy. Minus D module source path is gonna be, first you see the source directory is the name of the module. So this is not SRC, it's the name of the module. This is gonna give you, it's like when you're searching for code, this is like this it's not a package name. The module name is not like bz/sty/logger. It's bz.sty.logger. So the directory name has the dots inside. No, it's not like a package. We'll see how it looks. Then I'll say logger, and then I'll say, what will I say? Oh yeah, I'll say all the I'll compile in here. Before I do that, is it like visible? Okay, so we know it's empty. Nothing inside. We'll compile here. Module source path is logger. This is my IntelliJ module. And then I'll compile module info, and then I'll compile the, do you see what the difference is? So this is the module name, it's one directory. The package is 3 directories, and these things can be different. So it's not, they don't have to be the same. And then I'll compile my logger. Okay. So we have a directory, then we have several other directories, and this is the module. So when you require a module, the fully qualified name of the of a class in a module is the module name, the package name, and the class name. We'll see how this goes. I'll compile. So this is the compilation. The other thing is we'll create a main class that uses. So we have a module that requires. So this is not implicit. This is wrong. This is not implicit. It's a mistake. So I require this package. This module, I'm sorry, and my module is called this thing, and then I have my program Java that just says, in the main method just says log something. And then I do the module path and the module source path. So let's do it. I think this was called main. This is main. And I'll compile. The other class is this one, the program Java. So both guys have one class and one module info class. Oh yeah. Okay, this is from the next demo. I have to fix it. So we require this guy, and in the main method we have this is from the next demo. Oh yeah. Oh yeah. So what I'm missing here is this is the destination directory. This is where the source code is. This is where you look for the source code. This is the source code. It's a bit stupid because I already said where the source code is. And then I do module path is gonna be mods. So I'm gonna compile to mods, but I'm gonna use whatever is in mods. Well, line 4. Oh yeah. So it's gray, but gray doesn't mean not being used. Yeah. What I do have is one module, another module, all the classes. That's it. Now running everything together is, oh yeah, I can compile with a script, but we'll see that later. Oh yeah, so far so good. Minus MP minus M. Okay, so we'll see how this goes. So what I first, if you don't believe me, this is the 9 early access. So what I do is MP, which is like CP, like the class path, mods, and then I'll do minus run this module, and the module is gonna be yeah. So and it says logger hello world, and the logger comes from the previous module, which means that they all linked together, and this is what happened. So support for Jigsaw, only NetBeans, but we're not going to use it. Because of Jigsaw, Java 9 is going to be delayed since 2017. A couple of Spring guys on a like Jürgen Holler had said when it was this was the release date. Jürgen Holler said I definitely don't believe it's going to happen in 2016. It did not happen in 2016. He said I don't believe it's going to happen in March of 2017. There's a countdown. Can I? No, I can't. Oh, I can. Yeah, 300 days. Very cool. Packaging. So packaging is creating a jar file. Since I don't remember everything, I'm gonna do Alt Tab all the time. And I don't know how to zoom this thing here, and I'm gonna zoom the whole screen. No, is it in JLib? MLib. Yeah, we're gonna delete everything because you don't believe me. We'll create, no, that's not it, but I can, do the version thing, module version. And the file is gonna be, now this is important. So I'm gonna say the file name is this thing, right? But the module version is gonna be 299. We'll see which one stays, which one's the correct one. And then I have minus C mods and then this thing. If everything, I have one jar file. I'll compile the other one, the main class. So this is very, very slow because we don't have tools that do that. No version. We'll see minus minus main class. Yeah. It's gonna be minus C. Sorry about that. No tools again. What's the directory name? mlib. Yeah. So we have two jar files, right? One has a version, the other one doesn't. If I want to run something, I'll say jar minus mp mlib. So this is the module path, but this time it's not where the classes are, it's where the jars are. Minus m, and I just say that's it. Minus p. What did I do wrong? Oh yeah, I'm stupid. Java. I want to run it. And it works. How does it know where the main class is? The main class is specified in here as part of the jar file. Okay. And the jar file has nothing specific in it. Nothing special. What's in the jar? Can I print module descriptor? Please tell me I can print. Okay, I have it. What's in there? I have this module requires this module. Mandated means implicit, requires, like, is this visible? Requires this module, conceals the main. So if I depend on the main, I will not be able to use the main because it's not exported. But I can run it. And the main class is this thing, so pretty simple. Another thing I can show you is the print module descriptor with the version. So let's see how this goes. Print module description with the version isn't gonna work. So the version, so the file is called 2.0, but the metadata said the version is 299. So this is the actual, like, you should not do this, like, this is very confusing, but the version is part of the metadata. I don't know where in the metadata is. I looked in the meta.int file. I looked in, like, I don't know where it is. I decompiled the classes. I don't know where the metadata is stored for the version. Transitivity requires public. This is another very so what we'll do here is the main is gonna depend on these guys, and I'll have this thing, so I'll depend on a pretty logger. The pretty logger is another application in here that doesn't do anything special. When you say log, it does the same thing. It overrides the method but does exactly the same thing. We don't care about that. And what we'll do is we'll change the main to use the pretty logger. Now I'll use a trick to compile fast. Minus module source path is gonna be logger, pretty logger, main, and then we'll compile all the classes in these directories. Logger, pretty logger, main, because I'm lazy. The logger is missing. Oh yeah, it's missing because in the pretty logger we're missing Requires public. Okay, why is it missing? There requires pretty logger. In here, I require the pretty logger. Okay, am I missing something? Module path is this one. I'm not sure what the problem is. And since I don't have some time. What? Thank you. And then I have to go back and fix this guy. So I require only the pretty logger. So the important thing here is I require only this module. The other module is provided by this public keyword in here. So the pretty logger says, I require the logger, but I want everyone that requires me to receive access to the logger too. So if I do it, will it work? Cool, it works. And then if
these columns
I beg your pardon?
These columns in front of pretty logger and main.
The columns?
Touch it.
This is path separation in Linux. So this is the class path with colon, like in Linux is semicolon, in Windows is точка и запятая. The slash is, we don't need the slash. It's just autocomplete. It's directory, it's a list of directories. Okay, so if I run it, minus mp the mods, and then minus m the main program, it says logger hello world. It should say pretty logger hello world, because this guy does not say pretty logger. I have to compile again and run again, and it says pretty logger. So this is transitive dependency. We need to move on because I don't have any time left. I can say Java list mods, which lists all the modules in the Java. I can say, I can describe, I can list all of that. And then I have services. Services are really cool. It allows you to allow dependency injection in modules. And since I don't have much time, I'm gonna show you the pluggable logger. So in the pluggable logger, I have some stuff that says, like I have an interface. So I have a factory. This is a factory. And I say, like, getting the pluggable logger is an abstract method, right? And then the pluggable logger has a factory method that says, get all the implementations in the class path and find me the one that if there are pluggable, if there are implementations of my provider, and then return it. And then I just log the message. I have a implementation called superlogger, which has a provider, which implements my pluggable logger provider, that just returns a superlogger. The superlogger is just a class that implements pluggable logger and just overrides, doesn't do anything. Like, this is an abstract method. I can even delete this one because I don't like it red. And then what I can do is I can compile all of these guys. Pluggable, all of them. The module source path is gonna be pluggable logger, then pluggable logger implementation, and then pluggable logger example, main. So I compile all the three modules. We'll see how they work. And running them is gonna be like an, I gotta see what the main looks like. I don't remember all the package and the, so it's pluggable logger example, and then we have main program. So this is gonna be pluggable and this is gonna be, and the super logger works, which means I plugged it. So let's see what the code looks like. So we have the module info says I export these two packages and I use this provider, which means if anyone implements this thing, you can give it to me and it's gonna work. So this module will not work by itself. It's not complete. It means I depend on an implementation of this guy. Then the implementation says I provide the pluggable logger provider. I implement this interface with my class, right? The cool thing is the main class that depends on the pluggable logger does not need to know about the implementation class. It does not know about the implementation class. So it says, I require the pluggable logger. The pluggable logger is not complete. It has an abstract method, so it's not gonna work. So in order for me to work, I need to provide a module in the mods directory that implements. So I need, if I remove the super, if I remove if I remove the super logger to here and I run the thing again, it's gonna tell me no provider found, no implementations. I did not find any implementation. So it's implicit. You don't need to connect them. You need to put one abstract module with an abstract class or an interface, and then what happens is you need to provide one that works. And what happens is in this class, like, how do we get the right one? We get them by asking the virtual machine to give me all of the implementations, and I just get the first one. That's it. If I don't get the first one, I say no service providers found. If there are more than one, I just have to find the right one. Whichever comes first, whichever is more special, whatever. It's my thing. But this thing here, this list, comes from the system. So these are services, like dependency injection in Java. Really, really, really cool. So these are the classes, uses, and then we have the pluggable logger. We saw all that, the super logger, which is very, 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 very simple, and running it all together. And I'm not going to show you. This is just showing you how the resolving works, finding all the packages, resolving, and seeing where the stuff is. Custom GREs. I think I have 5 minutes. Is that correct? I have 15 minutes. Oh, then I don't need to be in a hurry. I can show you this thing. Where's the... I can show you the same minus diag resolver. So when I run it, I'll move this guy back together to mods. I'll see if that's, well, like easily visible. And if I run it again, it's gonna say super logger, which is my pluggable implementation, and worked. Minus X. So it resolved all the things I need. Okay. And now a very, very cool thing is I'm going to show you custom GREs, which is I have a tool called JLink. With it, I can combine the jars and the JMods from the Java home library, and I can create a customized GRE, which is very, 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 very cool. So it's a Java environment plus my application, only the stuff that my application needs from the GRE and my application bundled together. And this is very well if you read 9gag. So what I'll do is I'll try to be careful. JLink, yeah, go away. MP is, so I need the module path. I need my mlib, but I did not compile my pluggable. First, I need to compile I need to jar all my pluggable modules because the example is very cool. And I have to do it manually. Mods, where's the jar? I don't remember all the parameters. Create file module. File is, was it mlib? And this is gonna be jar. I'll set a version. It's gonna be 2.0. I'll say minus module version. Yeah, I don't remember all of them. I'll say, what else? That's it. Pluggable logger. I'm missing something. I don't need this guy here. Minus C specified. Am I missing something? Oh yeah. I have to specify the version. Thank you. Yeah, I messed it up again. Cannot skip the lines. This terminal is not very good. Then I'll do the same with superlogger. No version in here when I need it. Pluggable, this is gonna be superlogger. And then I'll compile the last one, which is gonna be pluggable logger example. And it's gonna be so I have the pluggable, I have the pluggable logger, the example, and the super logger. What I can do is mp is mlib, and I'm gonna do is again copy paste from the slides because I don't remember all the parameters. Add mods, module path. Okay, another directory we need to use is java home /jmods, and then add module, and I'll add the bz example. Example is the main method, that's it. And minus output, was it output? That is MP. I have to write it. Module path, there's no link. It's like minus help, minus help. Yeah, there's no, I have to write it. Minus, yeah. This is annoying. I'm gonna kill you. Add mods, yeah. Pfft. Kill me now. Pluggable logger example. Yeah, I'm an idiot. Finally, now we have a directory called live demo VM, which has everything. It has a bin Java. It has all the stuff. It has dylibs. It doesn't have, I don't know where the mods are. I really don't know. They're somewhere here. But if I do live bin Java list mods, it's gonna tell me that these modules are part of my custom Jerry. If I do Java minus list mods minus list mods, you see how many are in here. And what we can do is we'll see how big the Java home is. 400 megabytes. How big is my live demo VM? 30 megabytes. So it's smaller. Will my application work if I run it in the, like, I know you're not following, you will go home, but will my thing work if I do -m, because my application is part of the Java, so I don't need to provide an MP. Was it main? So the pluggable main is pluggable logger example, so it's very nice names, very nice names. Main program. Will this work? Let's bet. It's not gonna work because there's no service implementation. I did not add it. Like when I said add this module I added only this module, right? This module depends on this module, so this one is added implicitly. This one is added implicitly because everybody depends on it, but I did not add my so we'll do something else. Where's the J-link? We'll do add mods super logger, and I'll do whatever I always do. This what? Okay, very nice names for demos, extremely long names. So I just created another VM, and if I do this, I'll see that I have the super logger also. And if I do this, yeah, so I have 30 megabytes VM plus my application, everything's inside. Yeah, we go down. What we did not discuss in this talk because we don't have time. JDEPs, very cool tool that allows you to check if you're using internal APIs or if your code is messed up in some way that will not work for with Java 9. Unnamed modules, mixing old class path with new modules is either with unnamed modules or with automatic modules. Complicated stuff, we need another session for that. But you can mix and match. You can make your application modularized, and Hibernate can still be as a class path. That's okay. It will work. Support is, nobody supports that yet because they have a year to implement it, and the console is very difficult, as you saw. And mixing the class path and the module path it's gonna take some getting used to. You need to watch the sessions of Mark and Alan to see what happens. So that's it. Thank you. Any questions? Now's the time. You can ask in Bulgarian also. These guys wouldn't care about you. I'll get back bad grace, and that's on you. Like if I get bad feedback for the session. I don't know. Last time was in English, and I got bad feedbacks. Probably the session was bad. I don't know. We'll see. I beg your pardon? But the session sucks, right? Thank you. Give me good feedback. They'll send you an email. Fill it in.
Yes,
Give me all the. Thank you.
It seems very much like Node.js infrastructure, model infrastructure.
Yeah.
Is it a plan for a package JSON or something like declarative specification of model dependencies?
What?
Package JSON, I mean declarative specification.
Like downloading them like Maven?
If you want to use some modules with certain versions or versions and higher, you can declaratively specify your dependencies, and after that, just install it.
Maven is gonna support this thing, so Maven is gonna use the modules. It's Maven, Gradle, whatever. Like Java will not give you like a hubdocker.com. That's not. It's like Maven will give you that, or Gradle, or whoever. Like this is yeah.
How long do you think it would take for Maven developers to provide support? And it's also for IDE developers.
I'm pretty like NetBeans works.
NetBeans maybe?
Eclipse is gonna be slow. I'm pretty sure. IntelliJ, I don't know. I hope like until 2017 they'll have support. Like it's not very difficult. Maven, it probably will take more time. I don't know. And the versions, I don't know where the versions are used. I really don't understand why the versions are there. They don't talk about the versions. I don't know why the versions are there. So probably there's still work that's gonna happen in the next year. So when they release it, like the versions will be part of the metadata is there, but like me requiring a module, I don't state the version I require, which is crazy. I don't know why the versions are there. So probably some work will happen.
Are there any statements that the current version is complete and can be released, or still there will be some major changes?
I think that's the feature complete thing, like without the versions. They need to put some more stuff in the JDEPs and so on and so on and so on. And they will change the JMod file format, so we don't know. But probably this is how it's going to look at the end with minor changes. You can ask in Bulgarian, don't be shy. Okay, thank you.